subtopic is energy levels and electron arrangements. So the objective or the aim of this lesson is that by the end of the lesson, as a runner, you should be able to arrange electrons in the energy levels. Number two, you should be able to represent the electrons in a diagram. I want us to start by looking at what we looked at in our previous lesson. So in our previous lesson, we looked at the structure of an atom. What are the subatomic particles of an atom? Leonard? Correct. We have the protons, the neutrons, and then we have the electrons. In our last lesson, we also looked at the structure of an atom, and we said that an atom is made up of two regions. We have the inner region, that is the nucleus, and then we have the outer region, that is the region that is surrounding the nucleus, where we have the energy levels. Then we say that in the nucleus, so here we have the nucleus, we have the protons, and we have the neutrons. In our lesson today, we are going to look at what is around the nucleus, or the region around the nucleus, and this is what we refer to as the energy level. So around the nucleus, we have the energy levels, and these energy levels, this is where we have the electrons. So our today's lesson will be on the region that is around the nucleus. That is where we have the electrons. I want us to start with the energy levels. When you talk about the energy level, I've just mentioned that they are the regions surrounding the nucleus that are occupied by electrons. So the region that is around the nucleus, which is being occupied by electrons, is what we refer to as the energy levels. There are some things I want us to note about the energy levels. Number one is that the energy levels, because we have seen that they are around the nucleus, we number them starting with the energy level that is closest to the nucleus. So the energy level that is closest to the nucleus is the one that is we start with, then as we move outwards. So it is on the, we can see from the screen that when we are talking about the energy levels, I've said that we number them as starting with the one that is closest to the nucleus as we move outwards. Then there's something that I want us to note, that now that we have seen that we number them from the one that is next to the nucleus, the one that is immediately after the nucleus is our first energy level. Then after that, we have the second energy level, and then we have the third energy level. Then something else I want us to note is that electrons occupying the same energy level, they have approximately the same amount of energy. So electrons occupying the same energy level, they have approximately the same amount of energy. The other thing that I want us to note about the energy level is that each energy level has a maximum number of electrons that it can carry. Each energy level has a maximum number of electrons that it can carry. For example, energy level number one carries a maximum of 2 electrons. So the first energy level, the one that we have said is next to the nucleus, carries a maximum of 2 electrons. Then we have the second energy level. The second energy level carries a maximum of 8 electrons. The second energy level carries a maximum of 8 electrons. Then the third energy level. The maximum number of electrons that are carried by the third energy level will depend with the whether element that you're dealing with is in the first 20 element. So if you have an element that is among the first 20 elements, then the third energy level will accommodate a maximum of 8 electrons. That means if you have the elements with atomic number 1 to 20, they will have a maximum of 8 electrons in their third energy level. Any other atom that is not in the first 20 element, the third energy level will carry the third energy level will carry 18 electrons. So in the energy levels, we have seen that each energy level, there's a maximum number of electrons that it can carry. We have the first energy level, which is next to the nucleus. So we have our nucleus. So the first energy level here carries a maximum of 2 electrons. Then we have the second energy level, which we have said will carry a maximum of 20 electrons if the element that you're dealing with is among the 20 elements. If it is not, then it will carry a maximum of 18 electrons. Then we have the we have talked about the third energy level. The second energy level, we have said it has 8 electrons, so it carries a maximum of 8 electrons. The third one is the one that we have talked about, it carrying 8 electrons for the first 20 element, and 18 electrons for any other element. So now, having looked at the energy levels, I want us to look at how we arrange the electrons in the energy level. So I want us to look at electron configuration. Electron configuration. We are looking at electron configuration. So when we talk about electron configuration, it is also known as electron arrangement. When we talk about electron configuration, it is also known as electron arrangement. So when we are talking about electron configuration or electron arrangement, it is the distribution of electrons into the energy level. It is on the screen. You can check that we are saying that when you talk about electron configuration or arrangement, it is the distribution of electrons into the energy levels. How are the electrons being distributed down the energy level? Now that we have seen that we have different energy level, we have also indicated the maximum number of electrons each one of them can carry. For you to be able to write the electron configuration, or what we are referring to as the electron arrangement, it is important that you know the atomic number of the element that you're dealing with. Why? Because the atomic number of an element will be the same as the number of electrons in its atom. The atomic number will be the same as the number of electrons in its atom. I want us to look at a few examples. I want us to look at an example, hydrogen. So we have said that for you to be able to write the electron arrangement, it is necessary you know the atomic number of a given element. Ranas, who can remind us what is the atomic number of hydrogen? What is the atomic number of hydrogen? Correct, it is true. The atomic number of hydrogen is 1. So because hydrogen is atomic number 1, it means that its atom has 1 electron. That 1 electron is current in the first energy level because it has only 1. So that 1 electron will be carried in the first energy level. So the electron configuration or electron arrangement of hydrogen will be 1, just like that. Let's look at another element, boron. What is the atomic number of boron? Good. The atomic number of boron is 5. It means that it has 5 electrons in its atom. Now that we have seen that it has 5 electrons in its atom, then it means that these electrons are going to be distributed in different energy level. We start with the first energy level because we start with the first energy level, moving outwards. We said we number them starting from number 1, the one that is next to the nucleus, then the one that follows as you move outward. So in this case, because boron has 5 electrons, then 2 of the electrons will be held in the first energy level. So 2 electrons will be in the first energy level. Because we said in the first energy level, it can only accommodate a maximum of 2 electrons. So if it can accommodate a maximum of 2 electrons, it must be full. Now, if 2 electrons are accommodated in the first energy level, and we have a total of 5, it means that 5 minus 2, we are left with 3 electrons. So the 3 electrons will be, or will move to the next energy level, that is the second energy level. Between the electrons of one energy level and the other, we press a dot like that. And then now, the next number of electrons that will move to the second energy level, they are 3. So the electron arrangement of boron is 2, 3. The first energy level with 2, the second energy level with 3. Let's look at neon. What is the atomic number of neon, Ranat? Good. The atomic number of neon is 10. That means it has 10 electrons in its atom. So now that it has 10 electrons in its atom, we'll start with the first energy level. So the first energy level, we have said, accommodates a maximum of 2. So the first 2 electron will be in the first energy level. So 10, when you subtract the 2 that has been accommodated in the first energy level, we are left with 8, correct? So we'll be left with 8. The 8 electrons will be accommodated in, or will move to the next energy level, which is energy level number 2. So the electron configuration of neon is 2, 8. Look at that. For neon, the second energy level is completely filled up with electrons. Another one that I want us to look at is chlorine. What is the atomic number of chlorine? Good. The atomic number of chlorine is 17. What that means is that it has 17 electrons. Now, because it has 17 electrons, we start with the first energy level. So the first energy level will get the maximum number of electrons, which is 2. So when you subtract 17 minus 2, we are left with how many electrons? We are left with 15. The next energy level must be full. And we said that the second energy level accommodates a maximum of 8 electrons. So 8 will be accommodated in the second energy level. Let us check how many electrons that we have now. So they were 17. Already we have pressed 8 plus 2, which is 10. So how many electrons are remaining? 17 minus 10, which is 7. So the next 7 electrons will move to the third energy level. Like that. So the electron arrangement of chlorine is 2, 8, 7. Then I want us to look at another element here, potassium. We have potassium. What is the atomic number of potassium? Yes. The atomic number of potassium is 19. What that means is that we have 19 electrons in an atom of potassium. The atomic number of potassium is 19. So what that means is that potassium is among the elements that we talked about up in the energy level. Its atomic number is between 1 and 20. That means that because because of the number of electrons that we have, the third energy level, because it is in the first 20 element, will accommodate a maximum of 8. So let us distribute these electrons. So the first energy level will accommodate 2 electrons. So when you subtract 19 minus 2, what are you left with? 19 minus 2, what are we left with? 17, correct. Then we have the next energy level accommodating a maximum of 8. That is a maximum number of electrons that it can accommodate. Then, at this given point, we have 10 electrons. So 19 minus 10, 19 minus 10 is 9, correct? That means that the remaining number of electrons must move on to the next energy level. And I've just mentioned that 19 is among the elements that we talked about. That means that the third energy level for this given atom will accommodate a maximum of 8. So we have 8 electrons like that. Then, if you add the number of electrons that we have now, we have 18, because 2 plus 8 is 10. 10 plus 8, that gives us 18. 19 minus 8, now we are left with only 1 electron. So that 1 electron moves to the 4th energy level. So we have those as elements that are showing us how we can have or we can arrange our electrons in the energy level. It is very, very important for us to note that if we know the number of electrons in a given atom, then it is very easy for us to come up with the electron arrangement, as far as we can be able to remember that we have the maximum number of electrons that each of the energy level carries. So we have those ones as our example. If you look at the way we have represented the electron arrangement, we are just using number indicating the number of electrons in each energy level. Electron configuration can also be represented in a diagram. Electron arrangement can also be represented in a diagram. And when we are representing in a diagram, then we use either crosses or dots. So we can represent electrons using diagram, and when we are using diagrams, electrons will be represented either using crosses or dots. I want us to look at the elements that we have looked at here, or the atoms that we have looked at here, and then we now draw the diagram representing their electron arrangement. So we'll start with our first atom, that of hydrogen. So we have hydrogen, and we have from the above, we have said that from the above example, we have said that it has electron arrangement of 1. Now, we looked at the structure of the atom, and we said that the structure of atom, we have the nucleus. So even in this case, we must indicate the nucleus like that. And then in the nucleus, you can either use the chemical symbol, or you can indicate the number of protons and the number of neutrons in that given atom. In this case, hydrogen has only 1 proton. So I can indicate that in the nucleus. Then it has no neutron or 0 neutrons. So that is the content of my nucleus. Then it has only one energy level. It has only one energy level. So we indicate the energy level like that. And then we have only one. So we have said use either crosses or dots. So let's use a cross. So that one, this is a representation of hydrogen atom in a diagram. This one representing the energy level, and then we have the nucleus. I want us to look at the other element, which was boron. And we agreed that its electron arrangement, because it is atomic number 5, it has 5 electrons distributed as follows: 2, 3. What that means is that it has 1, 2. It has 2 energy levels. So we start always with the nucleus. So I have my nucleus there. And then after the nucleus, I have the first energy level. And then we have the second, because we have seen that it has only 2 energy levels. In the first energy level, we have 2 electrons, 1, 2. Then we have the second energy level, which has 3. So the 3 will be in the second energy level. Boron has 5 protons. Boron has 5 protons and 6 neutrons. So we have the nucleus there. And around the nucleus, we have the 2 energy levels and the electrons that are accommodated there. The next one that we looked at was neon. So neon, we said, has 10 electrons. So its electron configuration we have seen is 2, 8. Its electron configuration is 2, 8. So we start with what the content at the nucleus. So we have our nucleus there. We have the first energy level, the second energy level, because it has 2. Neon has 10 protons. It has 10 protons and 10 neutrons. It has 10 protons and 10 neutrons. Then move on to the first energy level. The first energy level has 2. So we have 2 electrons there. The second energy level has 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the electron configuration of neon will look like that in a diagram. Next, we looked at chlorine, which we said has 17 electrons. Therefore, its electron arrangement is 2, 8, 7. So this one has 3 energy levels. The first thing is we have said we start with the nucleus. So we have the nucleus there. Then this one has 1, 2, 3. It has 3 energy levels. So we have 1, 2, then 3. I'll start with the content in the nucleus. Chlorine has 17 protons and 18 neutrons. So chlorine has 17 protons and 18 neutrons. The next thing is I want now, in this case, we represent the electrons using the dots. So the first energy level has 2. The second energy level has 8. So in this case, I'm using dots to represent the electrons. So we have the second energy level there with the 8 electrons. The third energy level has 7. So an atom of chlorine, in an atom of chlorine, the electrons will be represented like that. 2 in the first energy level. Then we have 8 in the second energy level. And in the third energy level, we have 7. Lastly, we have potassium. Potassium is atomic number 19. That means it has 19 electrons in its atom. Electron configuration is 2, 8, 8, and then 1. So I want to represent these electrons in a diagram. So we have said that we start with the nucleus. So we have the nucleus there, which contains the protons. So the number of protons in potassium atom are 19. So it has 19 protons. And then it has 20 neutrons. 19 protons and 20 neutrons. And then the electrons are occupying 4 energy levels. So we have the first energy level, the second, the third, and then we have the fourth energy level. So the first one accommodates or carries 2. So we have 1, 2. The second, 8, 2, 3, 4, 5. Then we have the third one accommodating 8. And then we have the last energy level with only 1 electron. 2 in the first energy level. Then we have 8 in the second, 8 in the third, and the outer energy level has 1 electron. The other last example that we are looking at is calcium. Calcium is atomic number 20. So since it is atomic number 20, it means that it is going to accommodate 4 electrons, which are going to be distributed as follows. We have the first energy level, which we have said will carry a maximum of 2 electrons. So 2 will be the first energy level. So if 2 are in the first energy level, it means that we are left with 18 electrons. Then the next energy level will accommodate 8. So now we have a maximum, or we have a 10 electrons there. That means we still have 10 more electrons. We remember what we said, that the third energy level will carry a maximum of 8 if the element that you're dealing with is among the first 20 elements. And because it is in the first 20 elements, the third energy level will accommodate 8. So up to that given point, we have a maximum of, 18 electrons. So 18 electrons, we are left with 2 more electrons. So the 2 remaining electrons move to the 4th energy level like that. So we have electron arrangement of calcium being 2, 8, 8, 2. Then we start with the content of the nucleus. Calcium has 20 protons and it has 20 neutrons. Then from there, we look at we distribute the electrons in the energy level. We start with the first energy level. We have seen it has 2 electrons. The second one has 8. The third one 8. And the last one has 2. So we have the first there with 2 electrons. The second one, 8. And the third one with the maximum also, 8. And the fourth one with 2 electrons. So that is the representation of calcium in a diagram. Now, looking at what we have looked at, we have seen different electron arrangement of different atoms. From the electron arrangement of a given atom, we can see it is very easy for us to tell the number of energy level that are given, the number of energy level that a given atom has. Like in this case, we have potassium. From the electron arrangement, we can see that we have the first energy level, which has 2 electrons, the second one, which has 8, the third one has 8, and then the fourth one. So in total, potassium is having 4 energy level. Then there's something that is very important here that we need to note, the number of electrons in the outer, the last occupied energy level. So for potassium, we have 1 electron. So this is we have only 1 electron. So a very important information that we have 4 energy level for potassium, and then we have 1 electron in the outermost energy level. When we look at that for calcium, we have 2 electrons in the first energy level. Then we have 8 in the second, 8 in the third, and then in the 4th energy level, we have 2. What that means is that calcium atom has a total of 4 occupied energy level, and then it has 2 in the outermost energy level. I want us to look at the electron configuration of the following atom, and there's something that we are going to note. That of neon, we had previously looked at it, and we had seen that the electron configuration is 2-8. So we have 10 protons, and then we have 10 neutrons, and then we have its structure there. If you look at the structure of neon or its electron arrangement, we can be able to note that it is having 2 energy level. So it has occupied only 2 energy level, and then it has 8 number of electron in the outermost energy level. What that means is that its outer energy level, which is energy level number 2, it has the maximum number of electron that given energy level can accommodate. We are going to be looking at elements which have the outermost energy level being full in the next lesson. The next one is argon. Argon is atomic number 18, electron configuration 2, because we have the first energy level with 2 electrons, then the next energy level will have 8, and the third will have 8. So electron arrangement will be, we'll have 18 protons. It has 3 energy levels. So its structure looks like that. So for argon, the outer energy level has 8 electrons, meaning that that energy level is completely filled up with electron. So for the ones that have the outer energy level accommodating the maximum number of electrons that they can accommodate, then we talk of them being stable. Then we have seen that in other elements, we have them having different number of electrons. Like in this case, this one is has has 4 energy level. The last one has 2. We have looked at boron, which we have seen is atomic number 5. Electron configuration 2, 3. So the second energy level is having only 3 electrons. It is not a must for the energy level to be completely filled up. So it depends with the number of electron in a given atom. Now, having looked at those examples, we can conclude by saying that when it comes to the energy levels is the region around the nucleus. And then we have also said that when it comes to numbering the energy levels, you start with the one that is next to the nucleus as you move outwards. Something of importance noting is that the energy level are having a maximum number of electrons they can accommodate. So if it is the first energy level is accommodating a maximum of 2 electrons. The second energy level is accommodating a maximum of 8. And then the third energy level, we have seen that it will accommodate a maximum of 8 electrons for the first 20 elements. But if we have an atom that has more than 20 electrons, then it means that it will have a maximum of 18 electrons. Very important about the energy levels. Then electron arrangement. Electron arrangement, we have talked about different examples of how the electrons arrange themselves or they distribute themselves in energy levels. And we have seen that when it comes now to distribution of electrons in the energy level, this is what we are referring to as electron arrangement or electron configuration. And it will depend with the number of electrons in a given atom. Then we have looked at the diagram. So you can represent the electrons just by writing like the way we have done here, but still at the same time we can also represent them using diagrams. And we have seen that when you are using diagram, then the electrons are either represented by cross, like the examples that we have on the board, or they can be represented by dots. So if you don't use if you don't want to use the cross, you can use the dots. So at that given point, it is my hope that if you are given the number of electrons that a given atom has, then you can be able to use that information in arranging the electrons in the energy level. So to practice on that, I'm going to give you an assignment. So we have the assignment on the screen, whereby we are supposed to draw and show the electron arrangements of the following atoms. So we have the first one, which is beryllium, and we are given the number of electrons. So beryllium has 4 electrons. The other one is nitrogen. Nitrogen has 7 electrons. Lastly, we have then we have a fluorine. Fluorine has 9 electrons. Then we have phosphorus. Phosphorus has 15 electrons. So that is the assignment for today. You try to draw the diagram to show the electron arrangement of those atoms. So this one brings us to the end of our lesson this afternoon. I hope you've enjoyed. Until our next lesson, goodbye.